हाय, चलिए केमिकल कैनेटिक्स के एग्जाम्पलर क्वेश्चंस करते हैं. एज ऑलवेज ऑब्जेक्टिव सवाल करेंगे जो जेई और नीट के लिए हेल्पफुल हैं. कौन से? एमसीक्यूज, मोर देन वन करेक्ट एंड असर्शन रीजन एज ऑलवेज. ठीक है, चलो पहला सवाल राइट ओवर हियर. द रोल ऑफ अ कैटलिस्ट इज टू चेंज गिब्स एनर्जी ऑफ अ रिएक्शन. नो, एनर्जी नहीं बदलता है, एंथैल्पी नहीं, एक्टिवेशन एनर्जी. यस, ई ए इज व्हाट इट चेंजेस. या तो इफ दिस इज द ओरिजिनल एक्टिवेशन एनर्जी then maybe कम कर सकता है, बढ़ा भी सकता है. नेगेटिव, पॉजिटिव कैटलिस्ट एक्सेट्रा. दिस इज द आंसर टू दिस. इलेक्ट्रॉन कांस्टेंट नहीं बदलता है. In the presence of a catalyst, the heat evolved or absorbed during a reaction increases, decreases, remains unchanged. Yeah, I don't think the heat evolved. Yeah, that's the one. Same thing, same idea. इसे पूछा जा रहा है. Activation energy of a chemical reaction can be determined by determining activation energy. Okay, determine the rate constant at standard temperature. Interesting. You may be tempted to mark this, but देखो क्योंकि क्या क्या था तुम्हारा equation that k is equal to some constant a e power minus e a by r t. So you may be saying कि हाँ ठीक है, rate constant अगर मैं निकाला एक temperature पे तो I can get E A, but that's not the whole picture. तुमको A भी चाहिए. Without A you cannot find out E A. So इसीलिए you need the rate constant at two different temperatures. So two variables, two equations है ना. बेसिक्स ऑफ लीनियर इक्वेशंस, वेल नॉट नेसेसरी ना, बट दो वेरिएबल वाले इक्वेशंस है ना. ठीक है, डिटरमाइन प्रोबेबिलिटी ऑफ कोलिजन. दैट्स द फैक्टर ए. तो देखो दिस इज फाइंडिंग आउट टी. टी पे ए और दो वेरिएबल्स हैं इसमें भी. ठीक है, एनीवे नाइस क्वेश्चन, बट दिस आर राइट आंसर विच इज द सेकंड ऑप्शन. लेट्स गो टू द नेक्स्ट वन. कंसिडर फिगर 4.1 एंड मार्क द करेक्ट ऑप्शन. अच्छा ठीक है, ऑप्शन बाद में देखेंगे, बट इसमें हो क्या रहा है. प्रोडक्ट्स अगर ऊपर हैं रिएक्टेंट्स के, यानी कि ओवरऑल डेल्टा एच इज पॉजिटिव. क्यों? क्योंकि एच ऑफ प्रोडक्ट्स इज ग्रेटर देन एच ऑफ रिएक्टेंट्स. व्हाई? बिकॉज डेल्टा एच इज डेल्टा एच और एच प्रोडक्ट माइनस एच रिएक्टेंट है ना. ये बेसिक हमें कवर करिए. अब देखते हैं सवाल में क्या हो. मुझे लगता है इसी के बारे में कुछ होगा सवाल. एक्टिवेशन एनर्जी ऑफ फॉरवर्ड रिएक्शन इज E1 प्लस E2. ओके ठीक है, E1 प्लस E2 इज फॉरवर्ड रिएक्शन. दिस साउंड्स गुड. प्रोडक्ट इज लेस स्टेबल देन द रिएक्टेंट. यार यही मुझे सही लग रहा है क्योंकि अगर अगर प्रोडक्ट्स की एनर्जी ज्यादा है रिएक्टेंट से, दैट मींस दैट इट्स लेस स्टेबल. सो दिस वन मेक्स सेंस राइट देयर. बाकी देख लेते हैं. फॉरवर्ड रिएक्शन E2 प्रोडक्ट इज मोर स्टेबल. मोर स्टेबल तब होता अगर ग्राफ लुक समथिंग लाइक दिस. ठीक है, इन दैट केस इट वुड बी मोर स्टेबल. ये एसिम्पटोट्स है. ठीक है, दैट्स फाइन. Activation energy of both forward reaction E1 plus E2. No, 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 no. Backward reaction is E1. Okay. And forward reaction is E1 plus E2. ठीक है, that is sorted. Okay, great. What is the last option? Activation energy of backward reaction is E1. ठीक है, and product is more stable than the reactant. No, it's less stable. Close one, close one. See, confusing options, but luckily ये वाला option पहले आ गया, but confusing options otherwise. ध्यान से पढ़ने वाला सवाल. Consider first order gas phase decomposition reaction given over here. Okay, the initial pressure of the system before decomposition of A was Pi. After lapse of time t and total pressure of system increased by x units and pressure become Pt, the rate constant is given as what? Now ये सवाल if you solved the NCERT, this should be very chill. अगर आपने NCERT के सवाल नहीं देखा फिर भी हम लोग कर सकते हैं. I think something similar is there in NCERT, but that doesn't matter. Yeah, you can do it from first principle anyway. It's not that big a deal. What are you going to do? Write it. मैं फिर से इसको लिख देता हूँ. They are all gases. मैं फिर से नहीं लिख रहा हूँ that part. Okay, and you're starting at say whatever P I value, right? Pi is what you're starting off with, है ना. Initial pressure कहीं लिखा ना Pi. ठीक है, छोटा Pi. After lapse of time t, total pressure system increased by x units. This is very interesting and became Pt. So totally इसका Pi था और उसके बाद क्या होता है? Say Pi minus some y becomes y and then y. ठीक है. This is without the idea of x and all that. ठीक है, x कुछ और दिया हुआ है. But अगर मैं if I set this up from scratch, इसका जो quote unquote इक्विलिब्रियम, वेल यहाँ इक्विलिब्रियम नहीं है, बट इसका प्रोग्रेस ऑफ रिएक्शन ट्रैक करने के लिए ठीक है कुछ यहाँ पे कम हुआ जिसकी वजह से इसका प्रेशर उतना बढ़ गया. इंटरेस्टिंगली व्हाट यू गेट नाउ इफ आई ऐड दिस ऑल अप इज सिंपली Pi प्लस y, इन विच केस जो हमने y लिया है इज द सेम एज x. ठीक है, क्योंकि दिस इज गोइंग टू बी इक्वल टू Pt. अब ये मैं क्यों इतना लिख रहा हूँ? बिकॉज what you're going to have to do is find out rate constant for this. Now this is a first order reaction. This is the biggest hint over here. अगर first order reaction है, that means that Kt is going to be equal to ln of A naught by A, जहाँ पे A naught is the initial concentration or pressure and A is the final concentration of pressure, right? In this case हम लोग ये रखते हैं, ठीक है. So let me remove this and put this as Pi, and what is this? This is Pt. अब this is getting interesting now. यहाँ पे न्यूमरेटर में Pi सब जगह है, ठीक है, which means we are on the right track. But denominator में Pi और Pt का मिक्सचर है, मतलब कि अगर हम लोग Pt को हटा देंगे तो क्या हो जाएगा? That's interesting. Well, this is not Pt. Apologies. This is Pi minus y. हाँ, ये तो कुछ अजीब लिख दिया है. देखिए, this is the pressure of A after time t has passed. Denominator में तो वो होना चाहिए था, मैंने गलती से Pt लिख दिया था. Pt तो total pressure है, which is pressure of the whole vessel. उसकी जब all the gases vessel, उसकी बात नहीं कर रहे हम लोग. ठीक है. तो denominator में Pi minus y, इसको हम लोग y या फिर in this case x को, we have to find out what x is. And in this case, x or y is simply going to be equal to Pt minus Pi. खत्म हो गया यहाँ से. I don't think you're gonna actually take this much time in a test because you'll be like, अरे हम लोग तो इसके बारे में 1-2 मिनट से बात करें, इतना टाइम तो होता नहीं है MCQ में. Yeah, but that's why you gotta practice this sort of stuff. ये डायरेक्ट NCERT से आया हुआ है. I don't think it'll take you this much time. मैं धीरे धीरे कर रहा हूँ ताकि आपको डाउट ना हो कभी भी कुछ करने में. Anyway, if I just substitute that over here, that's interesting. अच्छा, x की वैल्यू ये हो गई. So Pi minus x की क्या वैल्यू होगी? Pi minus x is simply going to be equal to Pi minus Pt minus Pi, right? So then this becomes 2Pi minus Pt. अब ये इतना भी क्या बोलते हैं डायरेक्ट नहीं है. Like you can't guess this. You're like, why is there a minus sign, right? So unless you have a feel for the whole variables and all that, ये इतना डायरेक्ट नहीं है. तो एक दो बार आपको ये you have to have solved this to get an idea of how to get this. If not, then you spend a little bit of time figuring it out. I think this is the answer for this one. मेरे हिसाब से ये तो सबसे मजेदार सवाल है इस पूरे all of them, because I think this is the first time we spend so much effort in the exemplar question, right? Normally तुरंत हो जाता है and we just move on with it and all the things that we've done so far. But anyway, this is it. आगे बढ़ते हैं. According to Arrhenius equation, rate constant K is equal to something. Okay, ये तो हमने देखा ही था. Which of the following options represents graph of ln K versus 1 by T? If I take ले लेते हैं ना, you don't have to do anything from memory here. So ln K is going to be equal to ln A minus EA by RT. What are we plotting? We are plotting ln K versus 1 by T. So this becomes your Y now, and this right now 1 by T is your X equal to 1 by T, and M equal to minus EA by R. क्या कर रहे हैं हम लोग? We are writing the form of I equal to mx plus c. ठीक है? That's what we are doing, and this is your constant c. तो हर केस में कोई कांस्टेंट c यहाँ पे होना चाहिए. दिस केस कांस्टेंट c which is equal to ln a, सिर्फ इन दो केस में, इसमें नहीं है, इसमें नहीं है, so we don't look at that. इसमें है कांस्टेंट है, but it becomes negative, so this is a question mark. Let's see, देखा जाएगा. इसमें नहीं है तो let's remove that. Okay, अब क्या करें? स्लोप है नेगेटिव, that should give you the hint right away. अगर स्लोप नेगेटिव है, then only one that fits the bill is this type right here. ठीक है? That's it. Simple ग्राफ से, even if you don't remember anything, आपको बिल्कुल भी याद नहीं आती anything other than this expression, you can still figure out with just maths. इसलिए maths as a tool is lovely. Consider Arrhenius equation given below and mark the correct option. के काफी सवाल Arrhenius equation पे. Rate constant increases exponentially with increasing activation energy. नहीं तो भाई साहब, activation energy बढ़ेगा तो K कम हो जाएगा. Increasing activation नहीं, increase हटा दे. Decreasing rate constant increases exponentially, decreasing activation energy. ठीक है, ये वाला सही है. And decreasing temperature, no, and increasing temperature. Why? Because ये denominator में है. Denominator में है तो फिर कम होना चाहिए, but there's a negative sign there. Try it out. Put some numbers over here. Okay. 7th one is 4. Is just getting a feel of the mathematics. Okay, nothing else. Graph of volume of hydrogen released versus time for the reaction between zinc and dilute HCl is given in this figure. On the basis of this, mark the correct option. Averaging rate. अच्छा, ये तो बहुत funny चीज़ है, बहुत funky चीज़ है. funny नहीं, funky चीज़ है, मज़ेदार चीज़ है. ग्राफ का सवाल. I love graphs. ओके, एवरेज रेट अप टू 40 सेकेंड्स. ठीक है, यही निकालना है. अप टू 40 मतलब यहाँ से यहाँ तक, यहाँ से यहाँ तक. नाउ दिस इज, हम लोग इंस्टेंटेनियस रेट तो इस ग्राफ से निकाल सकते हैं. एवरेज रेट कैसे निकालेंगे? इज इट द सेम फॉर्मूला? कैन वी डू एवरेज रेट, इंस्टेंटेनियस रेट जस्ट बाय दिस? वेल, दिस वे थिंग्स गेट अ लिटिल बिट कॉम्प्लिकेटेड. ठीक है, लेट्स assume at this point, I know this is a scary assumption to make, that average rate is the same as instantaneous rate, because इस ग्राफ पे और कुछ तो दिया ही नहीं है. If we assume that, then any points on this line that you subtract should work, which means कि point V4 is not going to work. Okay, इस line पे नहीं है, तो V4 कहाँ पे है? V4 कहीं पे नहीं है. ठीक है, never mind. Okay, दैट वाज ग्रेट. और टाइम क्या है 40. तो डिनोमिनेटर में हमेशा 40 होना चाहिए. अगर डिनोमिनेटर में 40 है, नो दिस डज नॉट वर्क. अगर डिनोमिनेटर में 40 है, then I don't have anything at 0, right? I do not have the value of this thing at 0. That's weird. So this denominator of just being 40 does not work. So we got to look at the other options where 40 minus 30, 40 minus 20 दिया हुआ है. So if I do 40 minus 30, then it's V3 minus V2. मतलब ये हो गया सही. And if I do 40 minus 20, then it's V3 minus V1. मुझे दाल में कुछ काला लग रहा है. Now I'm getting both of these options to be correct. अब ये दोनों करेक्ट कैसे हो सकते हैं? Or did we mess something else up over here? Okay, let's write this down. Graph volume of hydrogen release with zinc and HCl. What's the whole thing? ZnCl2 plus HCl. No, क्या लिख रहे हैं हम लोग? Zinc plus HCl gives me ZnCl2 plus what else do you get? H2, right? I don't think this matters too much. हाँ, हम लोग को ग्राफ देख के ही जो करना है, एनालाइज करना है. मेरे हिसाब से ये अजीब सा चीज है. Mark the correct option. Average rate up to 40 seconds is V3 by 40. Oh, yeah, this works. This also works. V3 by 40. Yeah, 40 minus 0, V3 minus 0. ये भी सही है. तो what is this then? ये तो हमने क्या किया है? I think that was the weird thing that we did that was wrong, right? Average rate, ये दोनों हमने किए हैं. These are instantaneous rates. I said very confidently that let's assume that instantaneous is equal to average, which is not the case. So please don't do this. Instantaneous, मेरी spelling ऊपर की गलत है तो मैं इसको हटा रहा हूँ. But both this and this are instantaneous rates. Because वहाँ पे आप tangent का जो है slope निकाल रहे हैं, which is not what you need to do. So इसको सब हटा देते हैं and all we are going to do, average मतलब this value minus this value. ठीक है? तो इस if I were to draw a line between the 0 point and here and divide this up, तब होता है इसका value ये, which is simply going to be equal to V3 minus 0 divided by 40 minus 0. ठीक है? And hence the answer is this guy right here. Trust me, I was not trying to throw you off track or anything. कभी-कभी ये definitions can trip you up. Don't get tripped up on this. That's a good lesson from this question. Which of the following statements is not correct about order of reaction? Order of reaction can be fractional number. सही हो सकता है. Order of reaction experimental determined quantity. Yes. Order of reaction is always equal to sum of stoichiometric coefficients of reactant balance chemical reaction. No. This is only for a elementary reaction. अगर elementary नहीं है, तब ये नहीं होगा. If it's a complex reaction, then this is going to work. It's going to be the molecularity of the slowest step, the rate determining step. है ना? So 9 for this should be the right answer. Order of reaction, sum of powers, molar concentration, blah blah. ठीक है, सही है, ये बात सही है. Consider graph in 4.2. अच्छा, फिर से वहाँ पे बात कर रहे हैं. Oh, does not show instantaneous rate of reaction at 40th second. तो यहाँ पे जो हम लोगों ने किया था, तो ये दोनों, the reason why I did that now you'll see, is ये दोनों instantaneous rates हैं. तो V3 minus V2, V3 minus V1. चलो ये वाला ऑप्शन है, which means is correct and hence not the right answer. V3 minus V1, ये भी सही है, not the right answer. तो इन दोनों के बीच में हमको देखना है. V4 minus V2, V4 पॉइंट नहीं है ग्राफ पे. अगर V4 पॉइंट होता ग्राफ पे तो इंस्टेंटेनियस रेट हो सकता था, बट पॉइंट है ग्राफ में, मतलब लाइन पे नहीं है यार. इट्स नॉट ऑन दैट स्लोप, राइट? दिस इज द बेसिकली स्लोप ऑफ दिस जो टैंजेंट है, एंड सिंस पॉइंट V4 इज नॉट ऑन दैट टैंजेंट, हेंस दिस इज अ राइट आंसर एंड इंस्टेंटेनियस रेट नहीं दे रहा है. इनफैक्ट this will give you something even weirder. This will give you the average rate over 50 to 0 if you do that, maybe. Yeah, does it do that? No, it doesn't even do that, so forget it. V5 minus V2 by 50 minus 30, V5 minus V2 by 50 minus 30. Yeah, that does give you the instantaneous rate. ये भी देता है आपको. ठीक है? All right, awesome, lovely graph questions. Which of the following statements is correct? The rate of a reaction decreases with passage of time as the concentration of reactants decreases. Rate of a reaction with passage of time decreases. अच्छा, ये क्या है? Where have you seen this sort of thing? Let's read the other points. Rate of reaction is same at any point of time during reaction. Rate of reaction is independent of temperature change. Oh, that one's wrong. Rate of reaction depends on temperature. Rate of reaction decreases or increases with concentration of reactants. Rate of a reaction decreases or increases? No, ये गलत है. Increase होता है. So now both of these is talking about rate of reaction versus time. Where on earth have you seen that kind of a curve? Do you remember this at all? Well, if you are starting off with some products, yeah, this is the rate of products. गिरता गिरता जाता है और फिर constant हो जाता है. Similarly, द रेट ऑफ फॉर्मेशन ऑफ उल्टा बोला, ये प्रोडक्ट्स नहीं है, ये होगा रिएक्टेंट्स का। लाइक हे होल्ड ऑन, एक्चुअली इट डजंट मैटर व्हाट इज द रिएक्टेंट प्रोडक्ट, राइट? जो भी चीज़ ज़्यादा क्वांटिटी में है और वो रिएक्ट कर रही है उसको मैं रिएक्टेंट बुला रहा हूँ, ठीक है? तो अगर रेट ऑफ अ रिएक्टेंट इनिशियली बहुत ज़्यादा होता है बट विद टाइम इट स्लोज डाउन एंड इट फ्लैटन्स आउट। फ्लैटिंग पॉइंट का क्या मतलब है? इक्विलिब्रियम इज बीइंग एस्टैब्लिश्ड। उप्स, आई नीड टू मेक द बोथ इक्वल, राइट? आफ्टर पॉइंट इन टाइम, तो यहाँ पे है इक्विलिब्रियम एस्टैब्लिश हो रहा, तो ये है टाइम और ये है रेट। नीचे वाला क्या है? दिस इज रेट ऑफ फॉर्मेशन ऑफ प्रोडक्ट्स, जो इनिशियली सबसे ज़्यादा होता है, बहुत हाई होता है, देन इट स्लोज डाउन, द रेट्स बिकम इक्वल, दैट्स व्हेन इक्विलिब्रियम हैपेंस। अब ये पॉइंट क्या था? रेट ऑफ रिएक्शन डिक्रीज बाय सच टाइम और कंसंट्रेशन। यस, 11.1 शुड बी द आंसर फ्रॉम द ग्राफ। ये थियरी अगर नहीं पढ़ी है तो मेरे वीडियोस देखिए, प्लीज चेक द डिस्क्रिप्शन लिंक में, बेंटो लिंक में, all the videos on this theory, kinetics. Which of the following expressions is correct for the rate of reaction given below? Oh wow, fun times. 5 Br minus plus this, okay. Whew. Okay, so we have to figure bromine, bromide and H plus. Okay, just forget everything else. Just look at this. Looks like iska rate faster hai because for every 5 bromide ions, 6 H plus ions get reacted. मतलब H प्लस ज़्यादा जल्दी रिएक्ट हो रहा है एज कम्पेयर टू ब्रोमाइड। विद दैट इन माइंड, कैन यू लुक एट दिस एंड जस्ट से कि कौन सा, विच वन मेक सेंस ज़्यादा होना चाहिए? विच मीन्स कि H प्लस इज ग्रेटर देन डी ऑफ H प्लस बाई डी टी इज ग्रेटर देन डी ऑफ बी आर माइनस बाई डी टी, ठीक है, कूल। विच मीन्स दैट दिस इज द आंसर, राइट? दिस इज द ओनली केस जहाँ पे ब्रोमाइड का रेट इज लेस देन दैट ऑफ this thing. Otherwise, in all cases, bromide rate is more than that of this. That's it. दिमाग मत लगाओ. You can still do that. You know, 1/5. This is your standard way of doing it. No, wait, मैंने स्कूल में तो कुछ और पढ़ा गया। या भाई वैसा भी कर सकते हो. It's fine. You gotta look at maths problems and you gotta do them in, you know, as many different ways as possible, so that you understand the concept properly. ठीक है? Same चीज़ ही है. 5/5 ऊपर चला जाता है. जैसा करना चाहो करो. But I give you another way of doing such a question. Which of the following graphs represents an exothermic reaction? Exothermic मतलब final energy H is lower than H of products is less than that of H of reactants. Why? Because delta H is going to be equal to H of products minus H of reactant, which needs to be negative, and that's the only way this happens. In all of these, this is the only case where that happens. So it's only A, right? Are you sure? Can you be sure? यहाँ पे तो equal है. This is positive. So 13th वाला का आंसर होना चाहिए A only. Is it going too quickly? Well, this is a recorded video. You can pause कभी भी if you like, go back, hear it once again. But कोई भी theory मुश्किल लग रही है, please जाके video देखिए. Rate law for reaction is this, found to be this. Okay. Second order reaction, interesting. Concentration reactant of B is doubled, keeping concentration of A constant. Value of rate constant will, what? Value of rate constant? Huh? Why would the value of rate constant change? Is this like a trick question? Hold on. Concentration of reactant B is doubled, keeping the concentration of A constant, value of rate constant. Huh? I don't understand. Can we come back to this? This is a weird question. I mean, I'm pretty sure it's the same, but the answer key says it's doubled. Why would that happen? What do you think? We'll come back to this. Or maybe there's a typo. I don't know. I feel it's a typo because why would that happen? It makes no sense. Do you want to think about this for a second? Concentration of reactant B is doubled, keeping concentration constant. Value of rate constant. Rate constant क्या है? भाई ये है तुम्हारा rate constant, right? Rate constant. तो rate constant. इसमें नाम में ही constant है. क्यों बदलेगा ये? Strange times we live in. Maybe. Can you think of any way where this would happen? Yeah, it's okay. Take this time to pause. सोचो. कुछ हो रहा है क्या? कुछ नहीं हो रहा है ना. It's going to be the same, guys. Sometimes books have typos. Anyway, which of the following statements is incorrect about the collision theory of chemical reactions? It considers reacting molecule atoms to be hard spheres and ignores structural features. This is true. Number of effective collisions determines the rate of reaction. Number of effective collisions determines rate of reaction. Let's read the next one. Collision of atom molecules possessing sufficient threshold energy results in product formation. यार ये वाला तो सही है. Molecules collide with sufficient energy, threshold proper. See this is interesting. These both are related. This has a little extra information. This is saying threshold energy and proper orientation. This is saying only threshold energy, not so. Since इसमें ये orientation की बात नहीं हो रही है, hence I can confidently say कि ये वाला गलत है. ठीक है? जल्दी में मत आंसर करना. I know it looks like we are in a rapid fire kind of a mode, we are doing things quickly, but sometimes you got to slow things down as well. This is one of those questions. A first order reaction is 50% completed in some time. Okay, how much time will it take for 100% completion? Never. It's never gonna. That's a trick question, man. It's never gonna get completed. Infinite. It's an asymptote, right? It's like this. Just follow it, like forever and ever and ever. You can go 99.99999, but never fully. It's the beauty of nature. Compounds A and B react according to the following chemical reaction. Concentration of either A or B was changed. ये बहुत बार आता है, boards में भी आता है, सब जगह आता है. Keeping concentration of either one of the reactants constant and rates were measured as a function of initial concentration. Following results were obtained. Choose the correct option for the rate equations of this reaction. अच्छा, ठीक है. तो हम एक से दूसरे को डिवाइड करेंगे. So it's A par x, B par y equal to K times this is equal to your rate. Okay? Cool. Let's divide both of these things. अगर मैं इन दोनों को डिवाइड करता हूं तो क्या होता है? तब रेट 4 गुना बढ़ जाता है. देखो 0.4 डिवाइड बाय 0.2, वेयर एज B का कॉन्सेंट्रेशन इज जस्ट बीइंग डबल्ड. सो B की पावर है 2, विच मीन्स आंसर इज ऑप्शन 2. खत्म. लेट अस मूव ऑन. यू कैन do many different permutation combinations. Well, just 2 in this case. या तो इसको इससे डिवाइड करो या तो इससे दूसरे 1 and 3 से डिवाइड करोगे. But we got lucky there, I think. Which of the following statements is not correct for a catalyst? Yeah, whatever. If it catalyzes forward and backward reaction to the same extent. सही है. It alters delta G of the reaction. It's interesting. No, it does not. If a substance does not change, does not change the equilibrium constant of it is a substance that does not change the equilibrium constant. ये वाला भी सही है. It provides an alternate mechanism by reducing activation energy between reactant and products. What? Oh, not correct बोला था. 16.2 is right. I am a feeling 18.2 is right. I have a feeling ये भी गलत है because it need not all reduce, could also increase, right? Negative catalyst है ना? Possible है. Why not? इसीलिए जो चीज़ें लिखी जाती हैं थोड़ा ध्यान से लिखना चाहिए. I feel कि ये भी गलत हो सकता है. But if you get it in a test, just mark the second one for just to be safe because ये exemplar में दिया है and for some reason the JEE main does not really entertain questions on this front. अगर कुछ चीज़ें block हो रही हैं by my head, I apologize. I just realized कि I've been doing that a little bit. So yeah, sorry about that. I hope you'll be able to see things all the way through. The value of a rate constant of a pseudo first order reaction. Pseudo first order reaction. अच्छा. Depends on concentration of reactants present in a small amount. Depends on concentration of reactants present in excess. What? Why would it depend on the... Okay. You've got water, right? And hydrolysis of something happening. Do you know this example? ये आपने देखा है? Yeah? So water is a reactant and the reaction happens in water. So it's almost like you don't care about कितना पानी है. Well, because पानी सब जगह है. So it looks like the pseudo first order reaction, it looks like it would depend on the concentration of reactants present in a small amount. I'm pretty confident of this. But this is one of those questions जिसमें आपकी book में second दिया है. Like, why? I don't get it. If you feel strongly about it, let me know. I can give you an example, right? CH3, COO, CH3, पानी के साथ, acid catalyzed, क्या करता है? Gives you acid, दूसरा वाला acid, और gives you this, ठीक है? So then this becomes just K of acetate, okay? Water's in excess. So obviously it only depends on this, which is the stuff present in a smaller quantity. Whatever, man, whatever. I guess this is one of those exemplar books जिसमें कुछ ज़्यादा ही सवालों में अलग हमारे आंसर हैं from what is in the back of your book. It doesn't matter, we're sure about it. Consider the reactions. If you think otherwise, please comments में बताइए, Discord पे आइए. Discussions are always open. Consider the reaction A giving B, there's a double-head arrow, equilibrium है. The concentration of both the reactants and products varies exponentially with time. ठीक है. Which of the following figures correctly describes the change in concentration of reactants and products with time? Okay. आपको मैंने बताया था, देखो rate versus time equal हो रहे थे, which means concentration versus time ये वाला होगा. That's it. I've explained in detail how and why this works. If you still want to talk about it, concentration कम होता जाता है and constant हो जाता है. जब constant हो गया तो ये हो गया. अच्छा यहाँ नहीं हुआ ना, कहाँ हुआ? यहाँ पे constant हो गया ना concentration. This is equilibrium. Before that is your whole kinetics वाला study. उसके बाद equilibrium और thermodynamics में पढ़ेंगे आप इसके बारे में. These don't make sense. Well, this kind of could be, you could argue, saying कि अरे कुछ देर बाद ये C flat हो जाएगा. I mean, you can argue and hence mark this as well, but don't, right? The others don't make sense. Multiple choice questions, second type. Rate law cannot be determined from a balanced chemical equation if reverse reaction is involved. Yeah, bro, it can't. You need, if a reverse reaction is involved, you need to do K1A minus K2B and all that, etc. etc. I don't think we have done that in the theory so much, but check out my videos anyway. If not, zoom डाल से पढ़िए, उसमें है detail में. It's an elementary reaction. That's when it would work. So this is not right. This is a sequence of elementary reactions would not work. Any of the reactions in excess. यार ये भी सही है. अगर any of the reactions in excess we just saw, then pseudo order reaction हो जाता है. तो सोचना पड़ता है. Then things become even more complicated. Next सवाल. Which of the following statements are applicable to a balanced chemical equation of an independent reaction? Order is same as molecularity. Beautiful. Order is less than molecularity. No. Order is greater. No. What? Molecularity never be zero. Wow. That's weird question. In any unimolecular reaction, only one reactant species involved in the rate determining step. Unimolecular reaction. Yeah, that unimolecular मतलब वही जो एक molecule की बात कर रहे थे वही. The order and molecularity is slowest step is equal to 1. This is interesting. Order and molecularity of the slowest step is equal to 1. अच्छा इसको सोचना पड़ेगा. The molecularity of a reaction is 1 and order is 0. Okay. Both molecularity and order of the reaction are 1. अगर मैं 1 and 4 को सही मानता हूँ, which seems likely, then it kicks this one out. So we have to think a little bit on this one. In any unimolecular reaction, what is a unimolecular reaction? What could possibly happen? Okay. Well, can you think of any example where this would work? Can you think of any example where this would work? I think very confident 1 and 2 are correct. Order molecular slowest step are equal to 1. Yeah. But again, in your book, if you look at question 23, it gives you some weird answers. Both molecularity and order of reaction are 1. Well, this is a tough one to think of. Do you know of any unimolecular reactions? Do you think of any example? Let's look it up right now actually. देखते हैं. Unimolecular reaction example. Yeah, I'm going off script and we're going in detail. So decomposition of N2O4. आया याद यहाँ पे. N2O4 का decomposition gives you 2NO2. Yeah, decomposition reaction. ठीक है, cool. This is a first order reaction. Rate depends only on reactants concentration. ठीक है, cool. First order है. Okay, one reactant species. Okay. Both molecularity and order of reaction are 1. ये भी सही है. Molecularity of the reaction is 1 and order is 0. क्या zero order हो सकता है क्या? Can it be 0? I don't know. I don't think so actually. I don't think so. Hold on. Let's look it up. Where order is 0. देख लेते एक बार. मुझे तो नहीं लग रहा है. Oh wow. This is even more complicated. Yeah. हाँ मुझे हल्का सा लग रहा था. The reason why I'm looking it up is because hold on. ये वाला भी हो सकता है अगर तुम्हारा catalysis हो. But now we're getting into a very different territory, so I'm going to stop doing this because it would seem like either the book that you're referring to is completely off or what I'm saying is completely off. So, in the interest of what your book wants, NCERT, Exemplar, let's look at question 23. In this case, they're saying only 1 and 2 are right, but we can clearly see that even 4 is right? So, in that way, और जहाँ पे जो आपका वो दिया है वो गलत है. Lastly, molecularity of the reaction 1 and order is 0. Well, that's also possible, right? Yeah, I think. Oh, I get it. I think the reason why 4 can be wrong is because I just gave you an example where 0 हो सकता है order. ठीक है, I'm going to stick with NCERT is good on this. 1 and 2 are right. Let's move on. For a complex reaction, order of overall reaction is same as molecularity of slow step. बिल्कुल ठीक. Order of overall reaction is less than that of molecularity. Why? What does that mean? Order of overall reaction is greater than molecularity. No. What? The 3 are talking about the same thing. Molecularity of slowest step is never 0 non-integer. ठीक है, cool. That is obvious because elementary होना चाहिए that step and hence that becomes order, so it has to be an integer greater than 0. Okay, positive integer. 24, 1 and 4. Yeah, let's move on. At high pressure, following reaction is 0 order. Oh, look at that. Here's another example of a 0 order reaction. They are very complicated. Which of the following options is correct for this relationship? Rate of reaction is rate constant. ठीक है, ये सही लग रहा है. R equal to rate equal to K part 0, whatever A is, right? So it's just K. Sure, that one works. Rate of reaction depends on concentration in ammonia. Does it now? Huh. This is interesting. Rate of reaction depends on concentration. We just said it does not. So then why would it? Right? Rate of decomposition of ammonia will remain constant until ammonia disappears completely. Rate of decomposition of ammonia. Okay. If this is the rate of decomposition of ammonia, will remain constant until ammonia disappears completely. Poof. Wow. Okay. So rate with time. Now this is one of those weird things that never really reaches equilibrium. Hai. This is what it means. Rate is the same. No, it's not. This is showing a wrong picture. It's saying this is what it will be. It's always at equilibrium. Sorry, galat ho gaya udhar. That was showing the rate is increasing. Rate is constant. ठीक है. Further increase in pressure will change the rate of reaction. Further increase in pressure will change the rate of reaction. Yeah, it's just literally said here. At high pressure, it does that. Just said that. So 1, 3, and 4. There you go. During decomposition of an activated complex. Activated complex मतलब कि अच्छा that EA जो ऊपर वाला चीज था. This top thing here is the activated complex. Energy is always released. Energy is always absorbed. Energy does not change. Reactants may be formed. This is interesting. You see why I'm a little confused about this one? Because अच्छा हाँ नहीं ये वाला सही है हाँ. Basically either way you are falling off the energy hill, right? हम लोग ऊपर थे उससे ऊपर whether it goes towards the reactant side or the product side दोनों तरीके में energy कम हो रही है. तो this one is good. You are right. Energy is always released. Energy always does not make sense. Energy does not change. Energy, of course it does. We just saw that. Reactants may be formed. यहाँ reactants बन सकता है, product दोनों बन सकता है. That's what we are talking about, right? We are plotting H versus Q reaction coefficient. अगर वो वाला ग्राफ याद नहीं है, please जाके देख लेना. According to Maxwell-Boltzmann distribution of energy, fraction of molecules with most probable kinetic energy decrease at higher temperatures. Oh, this is interesting. It's lovely. It looks something like this. Okay. Now, what are we plotting? We're plotting fraction of molecules here, right? Versus, what is this here? This is velocity. Or you could say energy. ठीक है, energy, velocity, कुछ भी हो सकता है. You can plot either of those things. Now, let's say energy. ठीक है. Now, if I increase the temperature, then what happens? क्या होगा, क्या होगा, क्या होगा? Well, the total energy needs to be the same, which means the total fraction of molecule need to be the same. Fraction of molecule, they need to add up to 1. Total area of this needs to be same. तो वो कैसे होगा area same? This curve flattens out थोड़ा सा and also spreads out. क्यों? क्योंकि total area under the curve needs to be the same. ये थोड़ा ठीक से draw नहीं हुआ, but artist तो नहीं है हम. ठीक है. This is at T2, this is at T1. थोड़ा theory कर ही लेते हैं. T2 is greater than T1. What does this mean? This means that if I have most probable kinetic energy, it means this is the MPS, V MPS, most probable speed. Kinetic energy is half mv MPS square. Okay, fractional molecules with most probable kinetic energy decrease at higher temperatures. Yes, fractional molecules कम हो गए, which seems counterintuitive. इसलिए मैंने पूरा ग्राफ ड्रॉ किया. ठीक है. Most probable kinetic energy increase at higher temperatures. Most probable kinetic energy increase at higher temperatures. Yes, that is also true, right? This is your higher most probable kinetic energy. So 28 is 1 and 3. इसीलिए मैंने वो ग्राफ बैठ के ड्रॉ किया. Wait, kinetic energy increases at higher temperature. सही तो है. This is weird. Hold on. 27, not 20. No, 20. What? This is not 28. Wow, dude. Like, come on. This book needs to be printed again. 27 is 1 and 3. In the graph showing Maxwell distribution. देखिए इसलिए मैंने graph draw किया था. Area under the curve must not change the increase in temperature. Yes, exactly. क्यों? क्योंकि fractional molecules that you are plotting versus energy, right? Well, velocity energy is right. Fractional molecules भाई total तो 1 ही होगा fraction, है ना? You're normalizing and all of that. ठीक है. Area under the curve increases. No, it does not. Area under the curve decreases with increase in temperature. No, it does not. With increase in temperature, curve broadens and shifts to the right of the hand side. अरे वाह वाह वाह. देखो इसलिए किया था अंतर्यामी. Now, I honestly again did not know that this was coming up right now, right after this. It just makes sense to talk about this. Yeah, talk about both of these things together. There is graph पूरा draw करें. मुझे graph पसंद है इसलिए मैंने draw कर दिया. Luckily, we are reaping the benefits of that. So 28th rightly is 1 and 4. 29. Which of the following statements are in accordance with Arrhenius equation? Rate of reaction increases, increase in temperature? Ji huzur. Rate of reaction increases, decrease in characterization? Ji huzur. Rate constant decreases exponentially? No, it does not. Rate constant decreases exponentially. No, it increases. Rate of reaction decreases, it decreases? No, it does not. It increases. ये दोनों opposite statements है. So 29 is again 1 and 2. भाई काफी सवाल हमने कर लिए. ज़्यादा सवाल है इसमें. Okay. Mark the incorrect statements. Catalyst provides an alternate pathway. It does. Hence not incorrect. Catalyst raises activation energy. Yeah, that does. Lowers. Yeah, it does. Catalyst alters enthalpy of change. No, it does not. मेरे हिसाब से सिर्फ ये वाला आंसर सही है. But again, your book is saying कि ये वाला गलत है. But no, negative catalyst would do it. So मेरे हिसाब से the only one that's correct is this and not these. Which of the following graphs is correct for a zero order reaction? Zero. What is this? It's just constant. Reaction rate is constant with time. We just looked at that. Oh, this is the right one. This is the right one because it's constant and then it just falls to zero. I don't know what this is, but should just end here, right? There's no more reactant. I explained that to you on top. Okay. Concentration though exponentially कम होता जाता है, but exponentially कम होता है सीधा कम होता है. Well, okay. Concentration versus time. dA by dt is equal to K minus dA by dt. Hence, A naught minus A by T rather is equal to KT. ये negative line straight slope, and then needs to be an intercept. Be careful about it. So 31 should be 1 and 4, right? Okay, perfect. 32. Which of the following graphs is correct for a first order reaction? I love graphs. First order reaction. T half same hai? Yeah, it doesn't change with anything. T half, no, this is wrong. Molar concentration versus time. Oh, these are two interesting things. Concentration versus time. Yeah. ln A naught by A is equal to KT. Makes sense. This one's right. अगर इसी चीज को अरे अच्छा यही यहाँ पे coincidentally if I don't take the log it just becomes e power minus A naught by A. Hold on, that did not make sense. अगर उसको हम लोग ध्यान से करें तो how do we, yeah, e power minus KT is going to be equal to A by A naught, है ना? ये यहाँ पे सही लिखा है? Yeah. So if I do A naught by EA, let's do this properly, right? Just take the log out, it becomes A naught by A is equal to e power KT. This is getting very interesting because this graph works. Oh yeah. I was like, hold on, how is this a straight line? It needs to be curved. I was drawing the, yeah, ये वाला इधर जाएगा, ये वाला इधर आएगा. We are good. I was like, for a second, how is that a straight line? It needs to be curved, right? So yeah, ये वाला है right side में और ये वाला है left side में. So both of these graphs are correct. So 32 is 1, 3 and 4. Can happen to the best of us. Simulating your actual awesome, hey, hold on, 1, 3 and 4. If I do this A naught by A thing, is this correct? ln A naught by A is equal to KT. Yup. That's interesting. So if I take log to the base A, yeah, it should make sense. What's wrong with this here? In your NCERT वाला चीज, this guy is saying कि ये सही नहीं है. मुझे तो ये भी सही लग रहा है भाई. Are you serious? Am I tripping or is this also done incorrectly on your? Yeah, bro. What's up with this chapter? किसने बनाया? क्यों बनाया ऐसे? A little bit of hyperbole obviously, but please, अगर गलती से और अच्छी तरीके से कोई NCERT के रिप्रेजेंटेटिव इसको देख रहे हैं, मेरे से आपसे विनती है कि इस वाले PDF को फिर से बनाया जाए. सवाल बहुत प्यारे हैं, बहुत अच्छे हैं, बट इतने ज़्यादा डिस्क्रिपेंसीज हैं कि इट में कंफ्यूज स्टूडेंट्स. मुझे तो बहुत कंफ्यूजन हो रहा है, तो आई एम सेकंड गेसिंग माई सेल्फ. करिए ये तो सही है, गलत है, बट आई एम कॉन्फिडेंट. बट आप भी थोड़ा हेल्प करिए अगर आप इसको देख रहे हैं तो. खैर, एनीवे, दिस इज द राइट आंसर, ऑल ऑफ दीज. ओके, विद दैट वी आर डन. लेट्स मूव ऑन टू असर्शन रीजन, जो 3-4 आई गेस होंगे. कितने हैं? लेट्स सी. देयर यू गो. 5 ऑप्शंस. इसमें कोई जंबल नहीं हो रहा है. Both are correct and reasoning सही है. Reasoning does not explain the assertion, and then some permutation combination of all of these. We'll look at this. फिर से assertion is correct but reason incorrect. Both are wrong. एक सही है, एक गलत है. ठीक है. So you have to make sure that you read the, what do you call it, these 5 things properly, and we'll go over it. Order of reaction can be zero fraction. Yes. We cannot determine order from balanced electric reaction. Yes, दोनों सही हैं, but I don't think the reasoning is relevant. So this is going to be 2. Order and molecularity are same. Huh? No. Order is determined experimentally and molecularity is the sum of stoichiometric coefficients. Perfect, bro. So assertion galat, reason sahi. Assertion galat, reason sahi. So I think this one's 5. Okay, let's mark that here. As the enthalpy of a reaction remains constant in the presence of a catalyst. Sahi hai. Catalyst participating in reaction forms different activation complex, lowers down the activation energy, but difference in energy for reactant product remains the same. Difference. Yeah, dono sahi hai, but is this the right explanation? Let's think about it. Enthalpy reaction remains constant. Oh yeah, it remains constant because it doesn't mess around with the overall energy, it just changes activation energy. So sure, this one's 1. All collision of reactor molecules, no, only ones that have a proper orientation do that, only those collisions. That's literally this one, that's literally the answer to this. So 5, ye wala galat, ye wala sahi. Assertion reasoning, rate constants determined from Arrhenius equation are fairly accurate for simple as well as complex molecules. This is theoretical, fairly accurate. Dekhte hain. Wait, hold on. Complex molecule में तो तुम कर नहीं सकते हो because the whole orientation वाला business fails, right? So I think this one's wrong. Reactant molecules undergo chemical change irrespective of their orientation during collision. That one's wrong. I think दोनों गलत हैं. Is there something for दोनों गलत? Assertion is correct, but reason is incorrect, but दोनों गलत है. I'm not sure about this, right? I'm going to chalk this up to a doubt because your this says that this is correct. I'm going to take his word for it, but इसको थोड़ा पढ़ना पड़ेगा. What do you mean by complex molecules? And I don't think this is there in NCERT so much unless एक line कहीं पे छूटी हुई है. So anyway, that was it. That was chemical kinetics from me. What do you want me to do next? Let me know in the comments and Discord पे आइए. And in fact, maybe I'll post this link on that chemistry unbox to shout out to them. ज़रूर उनके लिए ये session किया गया था because they wanted kinetics. Thank you all. See you around.